Hi, my name is Kevin Moore. I'm a product manager on the Flutter and Dart team.
And my name is John. I'm a developer relations engineer on the Dart and Flutter team.
We are so excited to be here this year at I/O to talk about what's new in Flutter. So Flutter has 5 pillars that we're very proud of and excited about. And today we're going to talk about 5 new things in the Flutter ecosystem. But first, we are super excited to be welcomed to the Web 10 at I/O. Are there any web fans here? Awesome. A core pillar of Flutter is portability. In fact, in the last talk, Khan talked about how for first-party apps at Google, we can share 97% of code when using Flutter for cross-platform apps. We really care about portability. And 4 of the 5 things we're talking about today all run the web. So we think it's a great mix. And at the end, I'm super excited to talk about something very web-specific. So no guesses. So before we get into our 5 pillars and our 5 announcements, we thought it'd be good just to give an introduction to Flutter. Does that sound good?
Yeah, it sounds great. So building an app means really building multiple apps when you're doing traditional development. So you really pick a platform, and you have to build your app, and then when you want to pick another platform, you build your app again, and rinse and repeat. So this really slows down your developer velocity. Every feature you have to add, you add it to multiple platforms. So with Flutter, it's different because Flutter's portable, like Kevin mentioned. So you start by building your app, and then you can decide what platform you want to target first. And you can just keep going. You can pick another platform, pick the next platform, and so on. And you can do this without rewriting any of your code. So you really get to focus on what do you want to build rather than the target platform that you're building for.
But obviously, don't take our word for it. We have some super exciting applications that were launched just in last year that we're going to showcase today. First is Brickit. Brickit runs iOS and Android, uses on-device machine learning to look at a pile of your Lego bricks, figure out all the bricks you have, and then propose a model to build. It runs on iOS and Android. They were super excited about how much code they could share. And we asked, could you make us a web version for I/O? And they're actually able to get this app running on the web with WebAssembly in less than a week. An amazing example of AI and also Flutter's portability. Supercell is another app. Have people heard of Clash of Clans, right? These folks use a traditional game development kit, but they really wanted to share their code for account management, for friend management, and everything else. And they decided to go with Flutter. So now they have 3 published apps that are using Flutter for their account and user management and friend management in their apps. And they're actually excited to move to all the rest of their apps very soon using Flutter, just being able to share code. Similar to Supercell, Google Earth had a problem. They had a native stack. They used C++ to compile a very powerful, beautiful 3D representation of the entire Earth. But they had 2D controls on the left and the right, to look at information, to pick the views you're looking at, to get data from Wikipedia. And they had to rewrite this 3 times: Android, iOS, web. So they came to us. They worked with the Flutter team. And now they have one set of shared code. So this is actually a hybrid app with C++ and Flutter. And you have exactly identical behavior across iOS, Android, and web. And this is live now. If you go to earth.google.com.
And LG is using Flutter for their first-party applications on LG WebOS TVs. Yeah? I think we have some folks here today. They told us they love Flutter's low memory usage, productivity, performance, and our open source ecosystem. And next year, they plan to use Flutter on tens of millions of devices.
The experiences really are the stars of our show here. So we wanted to build an app that could take that vision well into the future.
When you visit Universal Destination Experiences, our goal is total immersion. Whether you need to navigate through the park or you need to order food directly from your phone, our app was built from the ground up to ensure you have the ultimate visit. And it's not just a map, it's your personalized guide, and it's your gateway into our connected experiences. And it's all at your fingertips.
2 years ago, as we thought about rebuilding the app, we really came to a pivotal spot. Do we stick with what we know, or do we really think beyond that? Think about something different, perhaps a cross-platform solution.
The transition to Flutter has given us opportunities to reduce the size of our app and has helped with consistency by giving us a single code base. We use Crashlytics, and when we rolled out our Flutter apps, we quickly saw the number of crashes go down to almost 0. And when we do have any issues, we've been able to correct them and push the fix out to the app and Play stores in less than 24 hours. Using Flutter enables us to future-proof the app, have increased scalability, and release quickly and often. This has proven especially useful in pairing the launch of in-park attractions with connected experiences within our app. Connected experiences allow us to go beyond the physical realm of what's in the park, and we can augment and personalize the experience for each guest. We originally built these experiences with a dedicated game engine, and moving them to Flutter allowed us to build something equally performant, but more lightweight and much easier to maintain as part of our core code base.
Our transition to Flutter has been seamless. We can build so much faster. What used to take us weeks now takes us days. And overwhelmingly on social and our qualitative feedback, it's been positive. And our App Store reviews are starting to spike. As you go into the park and you see people using the app, friends and families laughing, just having a great time. It's the ultimate reward knowing that the technology that you built is enriching the moments that make these memories last a lifetime.
Everything we do at Universal Destinations and Experiences really is based on years of innovation, creativity, and storytelling. We feel we're just scratching the surface of what we can do with Flutter in the future.
So as you can see, we have a lot of great Flutter customers using Flutter and having a lot of value they get out of it. And so Flutter has actually become the most popular cross-platform framework in the world, according to a recent survey. So that's Flutter. So Kevin, should we start looking at our pillars and our announcements?
I think that's a good idea. So we have 5 pillars, 5 announcements. Let's talk about the pillars first. First, Flutter is portable. You can run your code across 6 platforms: iOS, Android, desktop, and the web.
And Flutter helps you build beautiful applications by giving you control over every pixel. And you can lean into the platform default theme with Material, for example, or you can create a brand-specific experience.
Flutter is fast. We compile to native code on ARM, x86, RISC-V, JavaScript, and one more we'll talk about in a little bit.
And for developers, Flutter is productive. So stateful hot reload gives you instant changes without changing the state of your app. And we have great developer tools and code analysis with Dart.
And finally, Flutter is open. It's been open source since the beginning. We have a spectacular community, right? We have tens of thousands of packages in our ecosystem. We accept pull requests from hundreds of people every release. We're very proud to be open. One more click. Open.
Thank you. So let's talk about the Gemini ecosystem. Thanks, Kevin. So as you probably saw yesterday, Gemini is Google's most capable family of language models. And changes in AI have really changed the way we think about building apps. We're seeing developers embrace these AI tools and use the Gemini API to reimagine what's possible in an app. So that's why we launched the Google AI Dart SDK earlier this year. You can easily add text generation, summarization, chat, and more with minimal setup. And it lets you draw on the full family of Gemini models in your app, which lets you really lean on Google's research and development in this area. And because you built the app with Flutter, you can write it once and deploy it anywhere. So the best place to get started, as you saw, is Google AI Studio. It's a browser-based IDE for prototyping with generative models. And once you've got your prompt ready, it's really easy to get it integrated into your Flutter app. So you can run this command to add the Google Generative API AI package to your app, and you're ready to write some code. So here's an example of using the Gemini Pro model. I just create an object called the generative model. I can give it some content, which is our prompt, which can include text or image data. And the response can include text or images also. But there's a lot more you can do with Gemini and Flutter. So I recommend checking out this session on YouTube after the event and hear from Eric and Ander to learn more. And earlier today, Kaz and Khan shared how to build an app with an AI agent using Vertex AI Agent Builder, which is available on Google Cloud. So check out our YouTube channel if you're interested in learning about that too, if you missed it today. So there's a lot of exciting ways to use Gemini to create exciting AI experiences in your Flutter app. So go to flutter.dev/AI to learn more. So we're going to have some fun today. We're going to use our pillars as a scorecard here. So I think Gemini really represents Flutter's portability because you can write it once and run everywhere with Dart and Flutter. And it represents productivity because you could really get this started and get it integrated into your apps quickly. And of course, with Flutter and Dart, we integrate with all sorts of Google products like Firebase and Google Cloud really nicely. So that's Gemini. Let's talk about games. So some of you here know Flutter's great for building apps, but what about games? We see a lot of developers wanting to build games. Well, apps and games are a little different. So you can imagine with a Flutter app, you have widgets with text and layout and animations. And with a game, you might need a game loop, physics, 2D collision detection, things like that. So luckily, Flutter's framework is open. You can dig into lower layers of the layer cake here and really access these lower level capabilities. So Flame is a 2D game engine that uses Dart and Flutter, and it's built and maintained by our wonderful open source community, some of which are here today. So if you see Lucas, make sure you grab a Flame sticker after this talk. And with Flame, you can really bootstrap your game development using the same primitives I mentioned, like a game loop, 2D collision detection, things like that. So the Flame engine hooks into our layers in a kind of interesting way. So rather than just working at a top layer, it actually digs into lower layers of the framework, so it can provide these primitives, these APIs, without really rebuilding the rendering engine from scratch. So it's really leveraging some of these lower layers here to give you that higher level game API. And our tools are also open. So here's a video of me running a Flame game. And I've got Flutter DevTools loaded on the right, or the left-hand side here. So you can see with Flutter DevTools plugins, the Flame team built a plugin that lets you debug your Flame game using DevTools. So I can pause the game loop. I can select game components, which are a little different from widgets. I can see the positions of all the elements. And I can press play and continue running the game loop. So we think that's a great example of Flutter's openness here. Thank you. So if you're interested in getting started, we have some great resources available. We have this Casual Games Toolkit, which gives you a bunch of templates for getting started with game development in Flutter, like a basic game template, a card game template, and an endless runner like you see here. And you can find code for ads, persistence, crash analytics, and the game components that you need to get started. And you can also use Dartpad to play around with Flutter and games. Let me show you. So here I've got Dartpad running here. I can click Run and get some really quick feedback on my code. I'm just going to select this Flame game sample here, and I'm going to click Run. So it takes a second, which on a local machine, you have hot reload. It's going to be really fast when you're developing. In Dartpad, we send the code off to the server to get compiled to JavaScript. So here, I have my Flame game. Let's make a change. I'm going to scroll to the bottom here. I'm going to make the game a little harder because I don't have time to finish a full game of Breakout on stage. So let's change the game width, make that a little wider. I'll change the difficulty modifier, which is going to change the speed the ball increases when I hit one of the bricks. And I can just see what that change looks like. So I've made my change. The game's a little wider now. And if I click that, if I hit that, let's see if I can not mess this up. So it's going to increase the difficulty, and now it's too difficult for me. So that's how to play with games in Dartpad. And so we're really excited to see so many developers choosing Flutter to build games. And in fact, earlier this year, we launched the Global Gamers Challenge along with Global Citizen, which has inspired some of you to build games that inspire us to defend the planet for future generations. And the results have really been creative and exciting and fun. So let's show the top 10 winners. Pretty cool, right? Pretty cool. So if you're interested in getting started, we have some great resources available at I/O. We've got some code labs and a workshop. And so you can check out this workshop on YouTube if you missed it. This is Brett's workshop on building a 2D physics game with Flutter. So if you've got an idea for a game, we really think you're going to like choosing Flutter to build it. And games are a really great example of all of our pillars, I think. So I'm going to count all 5 on our scorecard. And to learn more about games, you can go to this URL. Now let's talk about Impeller. It's incredible. It's really incredible to think about all the technology that we have in our pockets. We can render really complex scenes really quickly, up to 120 frames per second on most phones, even low-end devices. And Flutter's original rendering engine, Skia, when it sees a complex series of draw operations, actually it compiles a shader to run on the GPU. And this can make the app really fast overall, but it causes apps to skip frames when they first need to draw a complex scene, like you see here. So if your app is displaying a lot of widgets when it boots up, it might skip frames, and your app might cause the user to think something is wrong. So when I asked our engineer working on Impeller what our strategy was here, this is what they told me. There's really no way to get around shader compilation without kind of rethinking your approach here. So that's what the team did, and the results are really incredible. So what is Impeller? It's a major rewrite of our graphics engine. It improves graphics performance by baking into the engine all the shaders that your app needs up front, using some techniques like tessellation. And it uses a new technique called stencil then cover in the latest release that uses a predictable set of shaders to draw these complex shapes. And so this is all so that you can build fast apps with Flutter without worrying about your app janking. And now that we have our rendering engine, we can invest in making our rendering engine faster also. So complex shapes like SVGs or Lottie animations run significantly faster on the latest version of Impeller, and blur effects run 2 times faster now on iOS. So last year at I/O, we announced Impeller was becoming the default renderer on iOS. And this year, we're excited to announce that Flutter is available on Android behind a flag for you to try out on the stable channel. And we're really aiming to make it the default renderer as soon as we can. So if you'd like to try it out, you can check out the latest stable channel and run Flutter Run with Enable Impeller or Flutter Build. And we hope you try it out and give us feedback. So that's Impeller. To learn more, check out our documentation. So I think it's really exciting to give apps this performance boost. And now Impeller is more portable. It can run on more devices, which is great. So now I'm going to hand it off to Kevin for our last 2 announcements. Thanks, Kevin.
Thank you, John. I didn't know we were scoring these. You get 3, and games got 5. Okay, and catch up. I still think I have the coolest ones. Macros. I haven't even started yet. Y'all excited? So Impeller is a great example of a multi-year investment that's paid off. We've talked about Impeller, I think, for 3 years now at I/O to see it actually ship. So macros, we're actually going to zoom back a little bit to something that we're just starting work on. So this is an experiment. But it's a great example of kind of the multi-year deep investments we're making in the stack. Macros is a feature in the Dart language that drives all of Flutter. And it's cool because I've been around for a number of big changes we made to Dart. We switched Dart from being an optionally typed language to a soundly typed language, which is kind of like changing the engine in an airplane while it's flying. We did it again with null safety, not only adding null safety to Dart, but doing it in a sound way that allows us to really optimize compilation. And now that we're completely sound, we're going to take it to 11 with macros. So let's zoom back and I'll talk about 2 language features that are really popular in the Dart language. People really want us to add native JSON support to Dart, and they really want us to add data classes. Did anyone else here want data classes? Yeah. Okay. So on the surface, these seem like easy things, right? Trivial. We'll add a to-JSON and from-JSON to objects, add an annotation, awesome. Data classes will just implement some features. Everyone's going to be delighted, right? Super easy, just add it to the language, ship it tomorrow. The problem is, it's not that easy. So in JSON, like what's the right thing to do if you hit null or a missing key? How do you handle mixed type keys or mixed casing in keys, right? How do you handle conversion? Do you do like, what's the RFC, date conversion? Do you store it as milliseconds or microseconds? Like, what's the way to encode a date time, right? In the data class side, how do you handle deep equals? Like, do you have to compare all the items in the list? If all the same items, the same order? Like, there's lots of questions here, right? It's not trivial. ToString, what's the format of toString? Can I customize how toString works in a data class? Like, all these features people want. Is JSON part of what you consider a data class? And so obviously the problem with both of these is, if you add these features to a language, it's fundamentally inflexible. We want to be careful about the features we offer. We want to think about it really hard. We want to evolve it very thoughtfully, which generally means evolution is slow. So that can be good at a language level, but if you're desperate to have the customized toString in data class, it's like you thumbs up an issue and wait. And we do have some features in the kind of Flutter and Dart ecosystem to handle some of these things. Package build, I think there's a few people here who've used the build package. So we do have a solution here, but it's a little cumbersome. It's not built into our tooling. You have to run it on the side. And it's generally kind of slow, because it has to rehydrate all of the objects, all the classes, and do its own thing. So with both JSON and data classes, and every other feature kind of in a similar vein, our thought was, let's move it up a level. So what does moving up the level mean? Macros. So this is an experimental feature as of May 2024, depending on when you're watching this video. And this is implementing something generally considered or called in the computer science realm meta programming. And meta meaning, so it's programs that write programs, right? Actually, go back a slide and I'll show a demo here. So, because JSON and data classes are complex, I'm going to do a much simpler example. It's called observable. So really quick here, let me see if I can close this. I have my little main function, initializing a user, and setting some fields. And then I have a couple fields down here. And you'll notice that up here I'm setting a property, a public age and name, and down here these are private, if you know Dart. So what's going on? Well, what we want to do is we want to track every time a field is set and do something. You might do this with an observable case. Maybe you're setting events when the field's changed. In this case, we just want to print. So this is VS Code with a latest dev build of Flutter and Dart. And you'll see this little go to augmentation feature. Let me split this right. So it's not format. I'm sorry for that. But you see the code here on the right. So this is the code that you would write if you wanted this, right? So I can see I'm defining a setter and a getter for age. And in the setter, I'm calling print and just declaring that I'm setting age to a new value and then setting the field. There's a few interesting things here that are new. First, you'll notice this augment keyword. This is actually a feature that's being added to the Dart language that you'll be able to use even without macros. For those that want to do, we call them partial classes in C#, something similar. So that feature is now available in Dart to be able to augment a class. This is not a mix-in. Like, you still have one definition of the type, which means you can access privates and everything else. This is also not a part file. You notice I can actually do imports in this augmentation, which you can't do in a part right now, which is super useful. And so let's add maybe a title in here. So I can go into here, switch my keyboard layout. Yes, I typed Dvorak, I'm weird. So you see I have a title thing. Let's just add observable. See how fast that is? It's my little helper, which is just amazing, right? In fact, I can open up my terminal. Let me run this. And see, so I can come in here and say, let's go, Jack, what's Jack's title? Let's make a doctor. So this is what you want, right? Like, I implement this, macro definition once, and then every field, I just annotate it, I get the feature. So this is interesting. I'm running in an analysis context. This is in VS Code, and running Dart Analyzer, right? And let's say when I edit the macro and mutate it, right? You think that must be kind of complicated, right? Because the analyzer is up and running. It's been instantiated by VS Code. And now I want to change the code that's running in the context of the analyzer to update the generated code. Sounds really hard, right? It's actually super easy. Barely an inconvenience. Let's go to the definition of observable. And see, here's the definition of the macro. You'll notice one more new keyword. We actually define a macro class. We actually lock down what we let you do inside a macro definition because this is going to run inside Dart static analysis when you're using your IDEs or doing your CI to validate your code. And it's also running inside Dart compilers when you compile the code. So there's no more running some external process or external thing, right? It's all running inside the Flutter tools. It's built in. So right now you see I'm saying setting the title. Let's go down this definition and say, maybe just say FYI instead. So let's see how fast this is. So let me be clear what's happening here. This code on the left is being analyzed by the analyzer. It's also being run inside the analyzer. As I'm editing this code on the left, it's being reanalyzed in the analyzer, rerun in the analyzer to update the generated code on the right. That's how fast macros are for enabling this kind of customization within Dart and Flutter apps. Really powerful. So you'll notice here really quick too, there's an error that's thrown if we're not private, right? You don't want to annotate an unprivate field. So let's go over here and change title and break the rules and make it a not private thing. And you see I got my little red squiggle. Invalid arguments. Observable cannot annotate a private field. So I just throw exceptions inside my macro implementation, and immediately we get feedback in the IDE. So we don't expect most users to write macros. We think other people will write them. But we really want to make sure that the user experience is spectacular. It should act just like we implemented the feature in Dart itself, but with the flexibility and the speed of having the ecosystem be able to run really fast, fork, patch, send PRs to modify these features. We're super excited. Back to slides. So macros, yeah, super cool. We already have a number of community members already playing with this. Again, I want to emphasize, as of May 2024, this is an experimental feature. We really want to make sure that we can add this flexibility without shooting anyone in the foot. So making sure that the performance is amazing, to make sure we handle badly behaving macros, to make sure the performance stays spectacular. We want to make sure we maintain everything that you already love about Flutter and Dart and just take it to 11 with macros. So check out this website to learn more. So not quite 5. I think the code personally is beautiful, and I think it runs really fast. I should have got 5 here, but we'll take 3. So obviously it runs everywhere Flutter runs, so super portable. We think it will dramatically improve the productivity of developers because now all this boilerplate, all this toil, just write a macro. And again, an amazing example of the openness of Flutter. Not just the open sourceness of Dart and Flutter, but the fact that as an ecosystem now, we can actually extend the Dart language via packages. We're super excited about macros. And finally, WebAssembly. This is the 3rd I.O. in a row I've talked about Flutter and WebAssembly. So I'm so excited. Hopefully I'll talk about it more, but to have it shipped makes me feel really good. So I think a few people in the room might know the history. The Flutter and Dart teams actually both started in the Chrome organization at Google, with a set of people who really dreamed about dramatically improving the experience you can have on the web, the performance, the fidelity of experiences on the web. And we had some bumps along the way and some missed opportunities and some things I think that didn't happen that I'm kind of glad didn't happen. But where we ended up in the end, I think, is a spectacular place for openness, for the velocity, and for the quality of experiences we can have on the web. But first, before I get into WebAssembly stuff, I'm going to step back a bit and talk about kind of how we think about Flutter and the web. And I want to start with websites. Actually, the 3 examples I'll give are the websites that our team controls. So Flutter.dev, Dart.dev, Pub.dev. These are the landing places you go if you want to learn about our languages and our tools, if you want to find all those great packages from our ecosystem. These are all written with normal HTML and CSS and JavaScript, unapologetically. That's the right tool for the job here. I think in some cases, some of that JavaScript might be sourced in Dart, and we compile it to JavaScript. But these are normal DOM sites, classic HTML. And that's the right solution for these kind of experiences. When you think about application experiences on the web, so the dev tools that John showed earlier that we use for you to modify, view, debug apps for Flutter and Dart. When you think about apps like Superlist, a great app that just launched in the last year for collaborative list making. For Rive, which does spectacular 2D vector art, graphics, animation that are used in apps all over the world. And Google Earth, like these nonlinear, not text-based, deeply interactive experiences. These are web apps, and this is what Flutter Web is for. We're building web applications. And today, we're excited that Flutter Web enables WebAssembly. Yeah, cool. So John showed the layer cake a little while ago, and this is how, to this point, we've deployed apps. So we do have an engine bit. It's actually authored in C++, and we've been using WebAssembly for years now. That's called CanvasKit. Skia is the source code. And then traditionally when you deploy to the web, so the entire Flutter framework, and that's kind of crazy, right? All of the layout, the animation, the input logic, all those things, gestures, that's all written in Dart code. The ecosystem packages that you use to access cameras and maps and everything else, those are all generally written in Dart as your application code. We take all that Dart code, and traditionally we've compiled it to JavaScript. But this idea of using WebAssembly has been around for a long time, right? So the Skia library that we use is sourced in C++. We compile that to WebAssembly, just like folks like Google Earth do, right? They take this big C++ app, they can run it natively, then they compile it to WebAssembly to have this amazing 3D experience on the web. So that's kind of where WebAssembly has been limited until very recently. Kind of traditional C, C++, Rust code. What was missing was handling garbage. And I was so happy to find this stock art. This is the coolest dump truck I've ever seen. As of October, the WebAssembly standard now supports garbage collection. This means languages that are traditionally garbage collected, of which Dart, are now natively available in WebAssembly, which means you have much smaller download sizes and hopefully much faster performance, because you actually can coordinate between the garbage collection for the language you're compiling in WebAssembly and the garbage collector in the browser. So this is a story available today in Flutter 2.2.2. We still have our WebAssembly bits, Skia, sourced from C++, but now the framework, the ecosystem bits, the packages, and the apps all compile to WebAssembly using the garbage collection feature. So as you can imagine, implementing a completely new compiler is not a small amount of work. It's actually a huge amount of work. That's why it's been a couple years. Why would we go through all that work? Performance. So we highlighted the wondrous demo before. This demo was only ever meant to run on mobile devices as a showcase of Flutter's native performance. We never imagined to run it on the web. And so we can benchmark the performance. And let's say that, establish a baseline running on my Pixel device of like 1x frame times. We took this app and we run it in JavaScript and just compared how long do the frames take to render. And in JavaScript, about 4x. So it works okay on a Pixel phone. There's some jank. But comparing a native experience compiled to native ARM code versus JavaScript, not too bad. When you compile to WebAssembly, we cut it in less than half. Yeah. And so all this budget now is the richness that you can add to your application, how down level and I guess affordable the devices you can target, because you can just get so much more done, so much more work in Flutter done compiling to WebAssembly. In fact, this chart I find the most interesting. So this is actually running on a desktop device. So percentiles, we'll get into math a little bit real quick. So at the 50th percentile, let's say we render 10,000 frames, right? So the median frame time, WebAssembly is about twice as fast as JavaScript. But so if we're just doing a simple, animation or a fade or a swipe or a scroll, about 2x faster. But as you get to the more expensive frames, the frames you're doing, like rebuilding the whole UI, the delta gets closer to 3 or 4x. So not only is WebAssembly faster, it's more consistently fast, especially in the most demanding frames, which means you have less jank, you can build richer experiences for your users. So this is available today in Flutter 2.2.2. Flutter 3.2.2. That's really hard to say. And if you want details of how to do this today, flutter.dev/wasm. We're excited for you to try it out. And it's only getting better. So WebAssembly, portable, because across all browsers that support the feature. Obviously, dramatically improving performance. And open. We're super excited to have collaborated with the Chrome folks. We filed bugs and collaborated with Mozilla folks. It was great to see the Kotlin, Wasm folks thumbs up a bug that we found on Mozilla, and they got things fixed. It's really a great place to work in this open source world. And that's our story. So John, we talked about 5 things today.
Yeah. We talked about Gemini, which showed you how to use the Google AI Dart SDK to add Google's most powerful models into your apps. And we talked about games, including the Global Gamers Challenge that we launched with Global Citizen, which has some great results, some great winners. And we have some incredible resources that we're sharing with you here at I/O to learn how to build games with Flutter. And we talked about Impeller, which is now available on Android, not just iOS.
We talked about macros, an experimental feature being added to the Dart language. We're excited for you to try out to really bring up the flexibility and openness of Dart and implement these features that you've always wanted directly in our tools and our compilers. And finally, we're announcing today with Flutter 3.22 stable support for WebAssembly, dramatically improving the performance of web applications with Flutter. So this is the slide to take a picture of if you have your cameras out. These are all Flutter, except for dart.dev. There's a Go macros if you want to learn more about all those things. And of course, the videos will be up very soon if you want access to those links. And of course,
You can just go to flutter.dev if you want to learn more.
to learn more. Thank you so much.
Thank you.